Hello everyone, welcome back. In this video, we'll understand about arrays. We'll first look at the introduction. We'll understand one-dimensional array, internal representation of an array, some programs on arrays. Now, what is the difference between a variable and an array? A variable is used to store a single value at a time. For example, ch is a variable of character type, n is a variable of int, price is of type float. Now each of these variables, they can store only one value. So I will have ch, n and price. I can store a character c, a value 10, a value 10.2. I cannot store more than one value into these variables. Such type of variables are called as scalar variables, also atomic variables. They are designed to store a single value. In contrast to these, there are something called as aggregate types, wherein they can store more than one values. Okay. Now aggregate type refers to both a structured type and a data structure, and they can be decomposed into a simpler elements by some defined structure. You also have operations for retrieving them and updating the individual values. Such type of data structure is called as an array. So ultimately, an array can store multiple values. Now why array? I want to read 100 numbers and I want to print them in reverse order. How can I do it with variables? I need to declare 100 variables, store values into them, and try to see which of them is last, and I need to print them in reverse order. Or I want to store marks of all 60 students in one data structure, find the average of the scored marks. It becomes really difficult when we look with variables. So after knowing the advantages of array, let us now understand one-dimensional array. Okay, so basically an array is a fundamental data structure that enables the storing and manipulation of potentially huge quantities of data. You can imagine the data as an image. Image is made up of pixel, and each of these pixels have values for intensity of R, red, green and blue. We need to store these values into a data structure. You can imagine how huge quantity of data it becomes if we are going for a larger image. So we can define an array is defined as a data structure consisting of individual data elements which are ordered. That is, one can count off the elements like 0th element, first element, second element, third element and so on. Array is of fixed size. Most important property is the elements are homogeneous. It means all elements are made up of same data type. If I declare it as int a of 10, it means all 10 elements are of integer type. If I declare float b of 50, It means all 50 elements are of floating type. Each array has two fundamental properties as discussed, the data type and the size. Now, elements of an array. Elements in the sense, if I have an array of size 3, this is an array A which can hold 3 elements. Let me give the values as 10, 20 and 30. These are the index values. So these are called elements. 10, 20 and 30 are called as elements. 0, 1, 2, these are called as index. This is called as a name of an array. Sometimes elements are also synonymously called as values. Index is also called as subscript. Okay, now this index is always of type integer. Values can be of any type defined by the user. Index always begins at 0 and is written inside the square bracket. For example, if I want to access 20 from this array A, I need to mention it as A of 1. So this is index mentioned inside a square bracket. A is the name of an array. I want to access this, that is, the value stored at this location will be stored into Z. In one-dimensional array, there will be a single subscript or index. Okay. For example, if I have something like this, int A of 10, right? So what is int here? What is int? Int is a data type. A is the name of array. 10 is basically size of the array. Size of the array. Now 3 things need to be specified. What are those? The type of data that you want array to store, the number of values it has to store, and the name of an array. So as mentioned here, data type, name of an array and the size. Always remember one thing, the range of indices, the lower bound is 0, the upper bound is size minus 1, and knowing these two, you can determine the size as upper bound plus 1. For example, if I have something like this, int A of 5, how will this be represented as? 1, 2, 3, 4, 5. Index will be 0, 1, 2, 3, 4. Elements will be 10, 20, 30, 40, 50. Okay. So the lower bound is always 0. Upper bound is size minus 1, 4. What is the size? Upper bound plus 1, that is 4 plus 1. So what are 10, 20, 30, 40 and 50? They are nothing but your values. They are nothing but your values. Now you need to be careful when you are declaring a one-dimensional array. I have listed few invalid declarations. You cannot declare an array without mentioning the size. You will have a compile time error. Similarly, you cannot have the n specified as the size without initializing this value n. Okay, in this case, some garbage value will be taken for this n. This is also an invalid declaration. However, this is a valid declaration. This is a valid declaration. I can define n before using it with the value and then declare the array by specifying n as the size. Here n is replaced with the assigned value 100. Now initialization of one dimensional array. As we initialize the variables, we can also initialize the array. However, there are two ways. One is compile time initialization and the other one is runtime initialization. Compile time initialization, the elements of the array are initialized when you compile the program, as and when you declare them. There are many ways of doing it. Initializing all the specified locations, partial array initialization, initialization without specifying the size, or you can even have string initialization. We'll have a look at it one by one. However, general form of array initialization is the data type, array name, in square bracket mention the size, in the curly bracket mention the list of values that you want to assign. And the second one is runtime initialization. So we'll look with one by one. Initializing all specified memory locations. Yes, the number of size, you have it as 5 and you want to initialize all the locations with these values. So during compilation, 5 contiguous memory locations are reserved by the compiler and these values will be stored into those locations. So it looks something like this: A of 0, A of 1, A of 2, A of 3 and A of 5. So 5 locations with values 10, 15, 1, 3, 20. So in the memory, if at all we assume the base address is 1000, the elements will be stored at the location 1000. Since integer is of 4 bytes, each location will be given 4 bytes of storage. So the next address will be 1004, 1008, 1012 and 1016. Now if at all you have something like this, A of 3 is equal to 92456. You are asking the compiler to allocate 3 locations, but you are storing 5 into it. In such case, a compiler will issue an error. Partial array initialization. If the number of values to be initialized is less than the size of the array, then the remaining locations will be automatically filled with zeros by your compiler. Here I have declared the size as 5, but I am initializing only the first 2 elements. So how will this be viewed as? So it is 10 and 15. The remaining elements are filled with zeros, right? However, if at all you want to initialize all the elements to 0, you can also do that, as A of 5 is equal to this. Initialization without mentioning the size, this is also valid. Now, depending upon the number of elements you specify in this curly bracket, your compiler will automatically determine the size of the array. For example, char A in the square bracket, I have not mentioned the size. However, in the curly brackets, I have mentioned the characters. Here, automatically, your compiler will take the size as 8. Now, how will this look inside your memory? So, it will be A of 0 will be C, A of 1 will be O, A of 2 will be M and so on. A of 7 will be R. Okay. Here, character occupies 1 byte. So, you just observe the addresses 1000, 1001, 1002 and so on up to 1007. String initialization, you can even do this, okay, wherein I can specify it inside the quotes. Okay, if you do this, the compiler will automatically append a null character to this and it will store it into the memory. So this looks something like this. We will be discussing about the strings in our next video. Now, runtime initialization, it happens using scanf statement. Okay, So when you are running the program, you ask the inputs from the user. Now one of the application of looping is this, that is reading and printing the array. Here just observe, I want to initialize the first 50 elements with 0 and next 50 elements with 1. How do I do it? For I equal to 0, I less than 100. If I is less than 50, sum of I is equal to 0, otherwise sum of I is equal to 1. Okay, remember one thing, when you are dealing with the array, subscript should be there. Subscript should be there. Otherwise, you will not be able to access the elements of the array. Some of the other allowed operations: increment the ith element. You can do it using this array of I. So you take the ith element and add 1 to it. You can add some value n to the ith element like this. A of I plus is equal to n. These are the compound statements. You can copy the ith element to the kth element in this fashion. As I just told you, subscript should be there whenever you are dealing with the arrays. Now, to copy complete array AR to BR, okay, how do you do it? You cannot do it as variables. This is wrong. This is wrong. However, you can do it using element by element, that is BR of I is equal to AR of I. Exchanging the values using a temporary variable. So use a temporary variable to store a value of an array, store this value and store temp in that particular value. Now just look at the internal representation of an array. So in C, the array is implemented as a single block of memory with element 0 occupying the first slot in that block. Arrays are allocated contiguous space in the memory. This is, you have to remember this, right? So if I ask for 100, the size of array as 100, so 100 locations will be reserved, that too contiguously. Now let us assume I want to store 10 elements and I declare this. I will have this initialization 1, 2, 3 up to so on 10. Let us assume the base address given by the compiler is 5000. Okay, now how do you determine the address of A of 8? Right? We'll just fill this and then have a generic formula. I will have 5012, 5016, 5020, 5024, 5028, 5032, 5036. Okay, the general formula to determine the address of this particular element is, here by the figure we'll get to know that it is 5028, but let us look at the general formula. So it is base address of A plus the subscript value into size of type of an array. So type of array is int whose size is 4, which comes out to be sorry, here I just wrote it, this should be 32 because we are looking for this. Okay, so this is 5032, right? Now coming to multi-dimensional array. So if at all an array is with 2 subscripts, it is called as a multi-dimensional array. One represents the rows and the other represent the column. Arrays with more than one dimension are called as multidimensional array. Now these multidimensional array find their applications in image processing, matrix processing, finding connectivity between the nodes, yes, and determining minimum spanning tree. Now how do you declare them? We have already understood declaration of one-dimensional array, so multi-dimensional array should not be a problem. Data type, array name. Instead of specifying one size, as in one-dimensional array, we specify two size. For example, int a 10 and 10. So the size of this will be 100. Okay? Yeah. Again, initialization, compile time initialization. We can do it by specifying the elements directly in the parenthesis. Okay, you can do this, or for every row you can specify the parenthesis. This is also correct. Okay, now just observe 3 and 4. Okay, this first subscript always indicates the row, second always indicates the column. Okay, so here it will be grid of 0 0 0 1 0 2 0 3, correct, 1 0 and 1 1. So in the matrix form, if I write, so you have 3 columns and 4 rows. So what will be the index of this? 0 0, 3 rows, 4 columns, 0 0 0 1 0 2 0 3, 1 0 1 1 1 2 1 3 2 0 2 1 2 2 2 3. This is how the indexes are written, and always the compiler starts filling the elements row wise. So if you observe here, 8, it is how it is stored: 8 6 4 1, then 9 3 1 1. The remaining elements will be filled with zeros. Okay. Yeah, as we discussed, the initialization of two-dimensional array is done in row order. First, the elements in the first row are initialized, then in the second row, and so on until all the initializations are done. Runtime initialization. In case of single subscript, we had used one for loop. However, for two-dimensional array, we need to make use of two for loops. One ranging from 0 to row size, other ranging from 0 to column size. Okay. Some programming examples. So most important application is dealing with matrix. How do you define a matrix as? A matrix is an ordered rectangular array of elements. Okay. Now if at all I want to find a transpose of a matrix, what do you mean by a transpose of a matrix? It is an exchange of rows to columns. So if at all you have an array as this 5 3 2 3 4 7 1 and 8 9 9, this will become as 5 4 8 2 7 9 and 3 1 9. So the rows are exchanged to columns. Now how do you go about this program? You have to read the input from the user. Runtime initialization. Read the elements, store it into this matrix. Right? Now just print the matrix. So till here it is common. Always you have to read and you have to print. Read a matrix and print a matrix. Okay. Now to find a transpose of a matrix, only changes this. For rows, I need to store the column, and column should become the rows. Also, while printing, I ranges from 0 to column, j ranges from 0 to row, print the transpose of the matrix. Right? On similar basis, determining the addition and subtraction of two matrices. The condition here is the order of two matrices must be same. Order of A and B should be same. Okay, so addition is nothing but element by element addition. So it is 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 2 is 5, and so on. Subtraction is also element by element. So have a look at this code. Yes, so here also reading and printing of two matrices must be done first, and then you perform the actual logic. But however, before proceeding further, you compare if row 1 is equal to row 2 and column 1 is equal to column 2. Then print addition is possible and you compute the addition. How do you do it? For I equal to 0 less than row 1, j equal to 0 less than column 1, you add element by element. As I told you before, whenever we are accessing single dimensional array, you need to mention one subscript. For two dimensional array, we are supposed to mention the two subscript. Then only your program will run appropriately. Is this clear? I hope you all have understood all the concepts with respect to matrix. Thank you.